Next speaker, Dr. GOPAL Agarwal. He is the chief instructor of the course, and his topic is IOL power selection using artificial intelligence. He is the ex-principal, School of Optometry and Orthopedics, Aligarh, and ex-deputy chief medical officer, Gandhi Eye Hospital, Aligarh, senior consultant at Kurji Hospital and AGRAWAL Eye Center and Research, Patna. He is the past president of Patna Ophthalmical Society, vice president of Bihar Ophthalmical Society, has several awards and presentations in state, national and international conferences. So it's over to you, the chief instructor, Dr. GOPAL Agarwal. And this is going to be a very interesting topic. I hope all of us will learn a lot as to what kind of IOL and what IOL is going to be the best for that particular patient. And that particular patient may be a VIP or a poor, but...
Good afternoon to everybody. My topic is IOL power selection using artificial intelligence. Here I will compare with the previous formulas, decision formulas, and recent artificial intelligence-based formulas. The purpose of this IC is to compare the accuracy of widely used IOL power calculation formula, including the artificial intelligence-based formula, namely Hill RBF, LEDAS formula, and very popularly now discussed nowadays, Keynes formula. Regression formula we all know: SRKT, Holiday 1, Hopper Q, Haigis, Barrett's, Oleson, and EVO. I have just new formulas I have only taken for comparison. Now, to calculate the IOL power, we have improved expensive machines, multiple formula of different situations, so we have many pearls. Even then, the results are not perfect in the regression formulas. They all require input data, regression-based calculation method, and have problems of ELP, which is still a challenging issue. No human can ever write a single formula that can take account every adjustment and variables. That's why for biometry, till now, we have used decision trees to decide which formula we should use for a particular case. That is cumbersome intuition and leads not a lot of experiences in regression type of formula. This intuition is mainly due to inaccurate calculation of expected lens position. But how can we convert this intuition into the approach that is easily available and useful to even the less experienced surgeons? Now, how to be close to the perfect IOL power calculation? Now, we have recession formulas like Barrett. No doubt it is very good. It is based on theoretical model. Consider the change in the principal planes among the variety of IOLs by means of lens formula. Estimate the ELP. That is very important. A estimate of ELP based on the anterior chamber lens depth or lens factor relation and actual position and the location of the principal plane of different power IOLs. Utilizes 5 variables that you all know. The Barrett 2 is addressed different IOL shapes and offers adjustment required for the low and negative power IOLs. Now, next is the Oleson formula. This is a new concept of the ray tracing assisted intraocular power calculation. It is the key feature of Oleson formula is the accurate estimation of IOL physical position using the newly developed concept of C constant calculated directly in the formula. C constant is the ratio of the preoperative thickness of the crystalline lens by which the IOL will locate itself following the bag implant. It also eliminates the ELP, so it is better than other regression formula and uses only K, axial length, and wide to wide. So there is no more guess like expected lens position, so it is better than others. EVO formula, that is Emmetropia Verifying Optical Formula. It is developed by Ton Kuo and it is based on the emmetropization and the generation of emmetropia factor for each eyes. Now version 2 has come for long and short eye and also for the toric, and it is also for the post-myopic refractive surgery prediction. So it is very revolutionary formula. It should be used in the pseudophakic IOL during the cataract surgery and not used for the refractive phakic IOL like ICL. Now come to the artificial based calculation. It is more to get more accurate result. We have artificial intelligence based calculation with two main approaches. Using the direct artificial intelligence approach by pattern recognition, that is Hill RBF, and using the sweet spots of multiple formulae. Here we create 3D surface from the big data collected from the sweet spot of multiple formulas. On entering the data, the perfect results are obtained by using artificial intelligence pattern recognition within the big data in Ladda's super formula developed by John Laddas. Sweet spots are the places where we get the maximum correct response for a given amount of inputs, because for the formula, not all the ranges of input given the results equally maximum correct response. I want to say that for each formula, we cannot get a good best result from every variables. There is such spots in any formula that we get the very good result. That is called the sweet spots. Now, how does artificial intelligence based formula works? When we upload the data of a patient, artificial intelligence based formula finds distinct pattern in the apparently random cloud of data points already created a large amount of cases based on the pattern recognition of artificial intelligence. Thus, it is a purely data-driven IOL power calculation approach, free from the limitation of expected lens position, and also free from the limitation of inherent standard formula. And this artificial based formula is adaptive. It is a dynamic learning process and continuously becoming better and better by updating itself, by entering the large number of surgical outcomes into the cloud. Just I have shown that is how it is data is input, and in the hidden layers there are variables. It can be 7 variables, 3 variables, and 4 variables. After the processing, we get the outcome is a very good results. Now Hill RBF formula, it has variables are AL, K, ACD, CCT, WTW, lens thickness, gender ethnicity. Limitation are inbound, prediction valuable reliable, and prediction value is higher probability, that is plus minus 0.5 of target outcome. Ladda's super formula based on the creating Ladda's super surfaces. Here is Ladda's super surfaces of any formula. In one axis, it is in the Z axis, it is the IOL power showing the axial length and corneal power in the XY axis. Now, Ladda's super formula is constructed using the sweet spots of 4 formulas: Hopper Q, Holiday 1 with Van-Koch adjustment, and Haggis. If first figures is sweet spots are each formula are presented in the colored diagram. Now they are all connected, and lastly Ladda's super surfaces is created by amalgamation of all 3s. Now this is the interface of Ladda's super formula. As soon as we give the input, we get this type of interface where we can see that there is the 3-dimension graph. The surgeon knows instantly if he is handling typical or unusual eyes. Now, if you compare with the Barrett universal formula, that is regression formula, here it says the Ladda's super formula gives the best possible calculated IOL power in all types of eye, including the extreme eye. Thus, edge over the Barrett's universal formula. These yellow blue areas are they are almost identical results, but in the red areas in the Barrett formula, they are varied from the Ladda's super formula, where the Ladda's super formula gives the better results. Now come to the Keynes formula, which is very common discussion nowadays. It also incorporates the artificial intelligence based formula. It requires parameter of axial length, K, ACD, gender, and A constant. It accurately measures the all range of axial length, but it is large cohort study and validation. To verify, I have conducted retrospective studies. I am not going in details, but the data which I have collected from my small hospitals, that is the mean numerical error for Hill RBF and Ladda's super formula, as the mean numerical error is very less. So it is better than other regression formula. In the mean absolute error, which has the basic of any correctness of the formula, here also the Hill RBF and LEDA super formula is better. If we sensitivity is taken, then the 0.5 diopter ranges is with the LEDA super formula and the Hill RBF. So they are all artificial intelligence formula, they are good. So LEDA super formula prediction is predicted more eye within the 0.5 diopter with spherical equivalent compared with the other formulas. For extremes eye, again, LEDA super formulas and other artificial based formulas are far better because mean arithmetic error is less than other regression formulas. For the toric IOLs, it is for your sake, it is the Barrett toric calculator, cylindrical part is very good. But if we add the LEDA super formula along with the Barrett toric calculator, we get the very good correct power from if you combine LEDA super and Barrett toric calculator. For the post-classic calculation, no artificial intelligence based formula is still present. To conclude, the advantage of artificial intelligence based formula, it is totally data driven based on the pattern recognition without estimating the expected lens position. Artificial intelligence based formula is continuously evolving, thus becoming more and more accurate. Accuracy above 90%. LEDA super formula is better and a single answer for any IOL power query, not with no outbound limitation as in Hill RBF. It incorporates the sweet spots of many existing formula into a single formula. It is time saving, no need to create calculation tree. Task of IOL power calculation can be delegated to the technician and the website does all the decision making. Ophthalmologists can now totally focus on surgery, leaving the mathematics to the artificial intelligence based formula. So LEDA super formula or any artificial intelligence based formula is a grandmaster of biometry and artificial intelligence being the game changer. Thank you for your kind attention.
Thank you, Dr. Agarwal, for giving us a super high concept on IOL calculation. I would just like to have your idea as to where to get the LEDAs and the Kane formula that you are talking about, which has got more accuracy according to you. How do you do that?
What?
The Kane formula and the LEDAs formula. How do you get that? Where is it? Is it available? If I want to do it, how can I do it?
No, it has come to the website also. It is also has come in the domain. So you can calculate it in that also.
Okay, right. So, is it in IOL Master or any other?
Yes, in one company that has come, most probably.
Anyway, but it is coming in any one of the IOL calculating machine. Maybe it will be available, right?
It is Kane, but I think that it is happened because validation is much more wide, should be much more wide, and much more investigation is needed. At present, the Barrett calculator for the toric part and LEDA super formula or Hill RBF formula for the spherical part is very good combination.
Yeah, that is available in most of the machines. I mean, yeah.
No. That is the problem. Only the problem is that we calculate the variables, and we put the variables into the clouds, and the cloud calculate with the deep learning method. No, it can be lens thickness, it can be ethnicity, it can be the sex. These are the variables.
The only what you are asking basically is the limitation of an optical IOL measuring devices, right? So with mature cataract, I think it cannot be achieved, I suppose. It has to be ultrasound based. So there may be an artificial intelligence device which is based on ultrasound technology.
That is the problem, that only thing that maturity of the cataract is the problem.
So with the permission of the